we've learned a lot about chemistry so far. You guys have been taken on a journey of one that you haven't really gone down yet, and we've learned about how chemicals can kind of come together, how they can form new things. We've talked about a couple different types of bonding, molecular and ionic bonding, and we've talked about chemical reactions specifically. But before we wrap up this unit, we got to do a little bit of tidying up. Namely, we got to put some of that stuff together. So we talked about chemical reactions, and we talked about like equations that explain chemical reactions. But now that we've actually talked about what chemical reactions are, the chemical bonding that's going on, why don't we revisit those chemical reactions? So how about this one, for example, an ionic bond. An ionic bond between, say, silver metal and bromine. So silver is a metal and bromine's a non-metal. So when they come together, they're going to ionically bond. And we can put that in a couple of different ways. We can write that as the chemical symbols. So the chemical symbol for silver is Ag, the chemical symbol for bromine is Br, and they get added together to form silver bromide. Now, here's the next step that we need to be able to take. We've written these equations before, but now that we've learned the naming rules for ionic bonding, we need to know how to take this equation and change it from chemical formula to a chemical name. So we'll look at Ag, we name that as silver, plus the bromine that we're putting together, and they form silver bromide. So now that you know the naming rules for ionic and molecular bonding, you should be able to convert chemical formulas into chemical names for equations as well. So another example, another ionic bond, if we were to chemically bond magnesium, Mg, with oxygen, O2, that gives us magnesium oxide. Again, you need to be able to move between the equation and the formula. Now, here's the tricky part. We don't always use the chemical names properly. We do have this English language that goes with our scientific one. So sometimes things like water are called water instead of their scientific name as dihydrogen monoxide. In the same way that like we can call salt when actually its scientific term, the IUPAC name for it, is sodium chloride. So there's a few chemicals that you need to memorize. Unfortunately, you need to know what's called their common names. So a few of the ones that you need to know water as H2O. You need to know hydrogen peroxide as H2O2. You need to know that salt is referring to sodium chloride, so NaCl. You need to know that methane is CH4. The glucose molecule, the one produced from photosynthesis, that all-important sugar, is C6H12O6. And you also need to know that rust is Fe2O3. So here's the tricky part. We need to put some of those common names into some of our word equations. You'll need to be able to draw on your memorized facts there that some of these common names you need to be able to show me the chemical formula for. So for example, if I was chemically combining methane with oxygen to form carbon dioxide and water, you need to be able to write the chemical formulas for that. So methane is CH4, and that's chemically combining with oxygen, so plus O2. That forms into carbon dioxide, CO2, and water. We recognize that as H2O. So jumping between chemical formulas and chemical names for equations. So that was a combustion chemical reaction, by the way. Remember, combustion is when a hydrocarbon anything made of carbon and hydrogen. So our methane was CH4. That's a hydrocarbon. When it chemically combines with oxygen, it releases a whole bunch of heat. And two things are produced. One being water, and the other one being carbon dioxide. That's combustion. There were two other special chemical reactions with oxygen that are required of us at this level. There's the corrosion chemical reactions and also cellular respiration. So all three of those are chemical reactions with oxygen. Remember, oxygen's a really reactive element. It loves to chemically react with things. So some of the most important chemical reactions on our planet come from reactions with oxygen. So cellular respiration. Let's go over that one now. We want to revisit them now that we can talk about them in terms of chemical equations, now that we're more comfortable with naming chemicals in general. So cellular respiration, that's what goes on inside of your body, inside of your cells. This is how you get energy. This is like when you run in the morning, or you even move your body. Getting out of bed requires some amount of actual energy. It requires chemical energy from your food. So your body uses that through the process of cellular respiration. So what does that chemical formula look like? Cellular respiration is when you chemically combine glucose with oxygen to burn it. It's actually a combustion chemical reaction, but it's a very specific combustion chemical reaction. It's one that you do inside your body. Again, so glucose chemically reacting with oxygen to produce carbon dioxide and water. And these are the things you breathe out. And then there's that energy that comes out as well, the thing that you capture and use and makes your muscles contract and do the things you need to do. Another chemical reaction with oxygen that you need to be aware of are corrosion chemical reactions. Lots of metals chemically react with oxygen. They form different types of rust, so to speak. Or tarnish as well. Like when silver rusts, it's called tarnishing. It goes like a blackish color instead of an orangey one. So anyway, the oxygen can chemically combine with metals, and they form these different rusts. So when iron chemically reacts with oxygen, so Fe chemically reacts with O2, you end up with Fe2O3. So if we turn that into the word equation, which is now expected of us, we can say iron plus oxygen gives us iron 3 oxide. So remember that iron is one of those polyionic elements in the periodic table, which means that it has a couple different charges that it can bond with. So iron, it can bond as a 2+ or a 3+. And if we have Fe2O3, we have to separate that out. Look, we've got 2 irons, we've got 3 oxygens. Oxygen always bonds with 2 negative. So we need to discover if the Fe is 2+ or 3+ by balancing our chemical formula. If oxygen is 6-, the only way that we can chemically combine iron with it in a 2:3 ratio is if it was iron 3+. If it was iron 2+, there'd only be 4 positive and 6 negative, and that's not balanced. So Fe2O3 requires iron 3. So remember that we have to assign it the appropriate name. So this is iron 3 oxide in our rust chemical reaction. That's it, that's all. We're done with our matter and chemical change unit now. So hopefully your brain knows lots of chemistries and you're awesome with it, and hope you had fun too, because it was a pretty sweet unit. Till next time.